I'm after school today. I'm helping out kids tutoring. A lot of BC kids need help. A lot of you guys need help as well. So how do I take a derivative of this function? Let's just say if I want to take a derivative of this h of x, right? And if I take a derivative of the left, I have to take a derivative of the right. So how do I take a derivative of h of x and f of x times g of x? And if I take a derivative of the one on the left, I'm going to get h prime of x. That's just the notations, right? And if I take a derivative to the right, I usually call it left d right, right d left, or it could be the other way around. The other way around. So sometimes we call it left d right. Oh, sorry, the other way around. It doesn't matter actually. Right d left. Yeah, right d left, and plus left d right. Okay, so let me erase that. Is right d left plus left d right. Now, in terms, the order doesn't matter. If right d left or left d right start first, it doesn't matter because they are addition. So what am I saying is, if assume that there was two functions, there was f of x and g of x. So what we're gonna do is right. We're gonna keep the right exactly the same, or we can take a derivative to the left, which is left, right? And we keep that plus and the plus f of x times g prime of x. Okay. Oops. Does that make sense or no? Right. Okay. Right d left and left d right. So basically, there was two functions. If two functions multiply each other, I'm going to use this thing called product rule. How do I know when it's two functions multiply each other? So at first case, we're going to give it to you is two function is f. We're going to say as this is h of x, and we're going to call this one is two functions. We're going to have two parentheses. First parenthesis is going to give me a 3x minus 2 x squared, and we have 5 plus 4x. Okay, so we have this function, and we're going to call this function is the g f of x, and this is g of x. So we have two functions. They are two parentheses. They multiply each other, and then we say, hey, can you take a derivative? Well, we're going to take a derivative by write down a prime, and we're going to follow that. So we're going to say right, which is the right function, d left, which is 3 minus 4x. Does that make sense? Plus left, right? Left, which is 3x minus 2x squared. D right, which is 4. And this is plus, not multiplying, is plus. Some of my BC Cal just now, I just corrected, is they write down times, but it's not times. So then this times this is equal to 15, and this times this is equal to minus 20x, plus 12x, and plus 16x squared. And then plus 12x minus 8x squared. And I might have make some mistake. Hold on a second. This is minus. I don't know why I keep on making mistake today. So that's equal to minus 24x squared plus 4x plus 15. And that will be my h prime of x. And basically just do the math after that. Only one line, which is a calculus right here. So this is a calculus. Am I going too fast? No?
I have a question. Like 4, where does the 5 goes?
Where's the what 5 goes?
Yeah, because when you know what h prime you're finding, it becomes a 4 instead of like 5 plus 4x.
Okay, derivative of 5 is 0. Derivative of any number is going to be automatic 0.
Okay.
Questions? Now, some people says, Mr. Ye, how about, can I just expand it first? Can I just do power rule? Yeah, of course you can. But the problem is today I want you to train the product rule because not all the time you can expand them, okay? Not all the time you can expand them. But I'm going to show you what happened. What if I expand them? Which is, this is the way not preferred, right? Today, we don't prefer this.
Please release your students for B1.
Today, right? Not prefer today. Today we will focus on product rule. But what if I just use a power rule? Can I do that? Of course. 3x minus 2x squared. Can I expand this? And then take a derivative with power rule? Worst, what comes worst? Well, I can. 3x times 5 is a 15x. 3x times 4x is equal to 12x squared minus 10x squared and minus 8x to the cube. And I can simplify this, 15x plus 2x squared and minus 8x cubed. I haven't taken derivative yet. Now I'm going to take a derivative. I'm going to rearrange this. It'll be negative 8x to the third plus 2x squared plus 15x. And I'll take a derivative of that. I'll move the 3 to the front. So it'll be negative 24 x squared. Take a 2 in the front, plus 4x, and plus 15. And you see this answer are the same. It proves to me that product rule works nonetheless. But today's homework, I don't prefer this. Why I don't prefer it? I will show you an example where it doesn't work. Okay, so right now I want you to practice. So let's just say h of x equal to 3x minus, I don't know, 4x to the second, and times 2 minus 8x squared. So I want you to, using product rule to do this, and check each other with the answers. And meanwhile, you're going to see a rabbit. Ax squared. And when you finish your problem, then you can check with each other, see what you get, right? You finish? You already finished. I graded.
You already graded it? Well, there was like one at the very bottom that I didn't simplify.
Let me see. You got an A, so I'm not worried about it. You have A.
Really?
Yeah, no, you don't deserve A, but you got A. I'm just kidding. I'm just kidding.
I studied for like 5 hours yesterday.
No, I know you did. Oh, let me wear my mask. Okay. Giselle, Luke, Katie, Gabby. Okay, so.
What is this one?
Yeah, no. You can look at it.
points at the very bottom.
Tiger. Mhm. I gave 10 points for everybody, so that's why.
Okay.
And you can look at the KP.
Oh, okay, thank you. So, if I look now, do you think I should still come to tutoring?
Well, you can come in, and I can give you the 5 point you're looking for, and you can help somebody out.
Okay,
Because I'm looking for people to help each other out.
okay. These are
But it's up to you. You don't have to come. Yeah. You can.
I'm gonna come to tutoring, but I have to leave at around 3 because I have a band practice.
Oh, top band. Screw the band. Band is overrated. Calculus is underrated.
Actually, no, I agree on that. Calculus is underrated.
I'm just kidding. Which instrument you play?
A drum. I play snare drum.
I graded yours though.
You already graded it?
Yeah.
I wasn't finished.
You didn't tell me that.
You didn't tell me, but you did good. Come here.
And then it would be
You did good.
Oh, I did.
That's what I said.
I
No,
walked
no,
out and went
I'm.
to the wrong class because I was like, nope, that was bad.
No, you did a lot of algebra stuff. That's kind of crazy. But yeah, I'm gonna show you how many things you did.
You went past me.
Where? Okay.
That's pretty good for me.
Yeah, that's not bad. Okay, so the only thing that I will say is you forgot for parentheses. I take out 2 points, and that's why your answer is kind of off the sign. This one you didn't know how to finish. I take out 5 points. This one's all good. This one you didn't know how to start, and you didn't know how to finish. This one I didn't take any points. Let me see, Matthias. There you go.
Thank you. I'm done.
Oh, you done?
Yeah, I did.
Oh, you just want me to grade it?
Yeah.
I
Or
haven't
actually,
graded
let me
yet.
see if I could work a little more in it.
Okay, yeah. If I were you, I'd probably. Okay, so yeah. Okay, so this is funny because low D high over low low.
Yeah.
I don't think you'll ever find that.
No.
I don't think you'll ever find that because it just looks too perfect. Because the other one answer just kind of off. It's actually really bad. And oh my goodness, 1/12 times 3/4. And you got 3/46. I have no idea how to get that.
I just multiplied it. 1 times 3, 12 times 4.
12 times 4 is what?
48. Wait, did I write down? Yeah, you can see where I wrote down 12 times 3.
What is 6? Dope. And I hear, yeah, I hear, look, you got 3/4, right? And then that's fine. And you could have just, this one, just, you got the right answer here. And the other one should be positive. Because 12 minus 3 is positive 9.
Yeah, you're right.
You know what? I'm gonna take out 1 point there. Just that's not even worth to take out 2 points. That's pretty pathetic to take out 2 points. I hear this is plus because of cosecant. Look, you're right down derivative. Now this one should take out 2 points.
Yeah.
But everything else you did good. Oh, this one's really bad. This one I take out 3. It's because you did everything perfectly. And you're not supposed to plug in 0 for this. You're supposed to solve for zeros.
Oh, yeah. I did do that, didn't I?
Yeah, I'm like, how'd you get 81? And I look at it. I was like, oh, 3 to the 4 power is 81.
Yeah. Okay, that all makes sense.
Yeah, so you didn't make any major mistakes. You didn't make any major mistakes, so it's not even worth it to have you come back. But you can come back help other students if you have. No, 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 in the afternoon.
Okay.
Because
I have a quick question about 14.
Sure.
So what should I have not factored in?
No, it's supposed to be cosecant, cosecant, right?
Okay, because I
So
missed like a 2 here. And I
So
don't
you
know
missed
where
a
that
2.
went.
I don't know. I only take out 2 points, so I didn't take out a lot.
Okay.
I know you did it right. You're missing a 2. I told you that you're missing a 2.
And then for this one, is it just like I didn't do parentheses and then that like derailed the whole thing?
Pretty much, because what happened is that parentheses is going to distribute everything.
Okay.
But I should not take out 5 point here. It's kind of petty.
Well, I mean, I forgot everything else wrong.
But a parentheses is like one of my big thing is like
Yeah.
kids need to know parentheses. And forgot about chain
Yeah,
rule. I think this
that's-
is kind of sad.
Yeah, no, it is sad.
This is kind
I
of
was,
sad.
I was punching the table.
You're punching the table. But yeah, other than that, you didn't do bad.
Okay.
Yeah. So yeah, you did good.
Alright, thank you.
But if you want to come back on the afternoon to help other students, I can put that 100. So
Yeah.
that way it looks nice.
Yeah.
It's up to you.
It'd help everything else, so I think I might.
True.
Thank you.
Okay, you guys doing good?
Kind of,
Okay, so
slow.
h of x, right? So I'm going to take a derivative of the first one. So it'll be 3 minus ax times 2 minus ax squared. Does that make sense? Plus 3x minus 4x squared times negative 16x. Does that make sense? Am I doing okay so far? And rest I'm just distributing, so 6 and minus 24x to the square. And then minus 16x and then plus 64x to the third. And this one's going to be minus 48x to the second and plus 64x to the third. Is that okay? Am I doing okay? So you should get 128x to the third minus 72x to the second and then minus 16x and then plus 6. That's fine? So that's product rule for you. Okay, so that's product rule for you. So if you did it right, it's going to be like this. Okay, so now we're going to say, why do we need a product rule if we can expand them? So the next case is going to be a little bit different. The next case is going to be y equal to 3x squared sine of x. Right? If I were to take a derivative in this case, I cannot expand them. So you have to treat it like there is a 2 parentheses here. It's like this. It's not 3x squared sine is a function. It's 3x squared is a function. Sine of x is a function. Now can I do the product rule? That sounds worse than mine. I think mine sounds bad. What's the derivative of sine of x? Do you guys remember? Cosine of x. Good. It doesn't help you, Logan.
I know.
Well, besides, you know your trick derivative of all the things.
I do.
So I'm going to take a derivative of this, right? So we didn't take a derivative, so it'll be 6x. Are we okay here? Times sine of x plus 3x squared times cosine of x. Does that make sense? And then you can factor this because sometimes they help to factor out GCF. What's the GCF between those two terms? x, what else? Between 3 and 6? 3. So then you can have this 2 sine of x plus x cosine of x. So it can be like this, because sometimes you need to solve for zeros, and this is very helpful if you know how to factor out stuff. Now I want to show you something that is very interesting. You guys know how to take a derivative of 3x squared, right? That's no problem, right? What is derivative of 3x squared?
6x.
Yeah, so ideally this is called a constant multiple rule. So constant multiple rule. And why is a constant multiple rule important? Because you can basically ignore this 3 and just take derivative of x squared. Does that make sense? We do that invisibly. But we take the 3 out and just say 3d to the dx over x squared, and that's equal to 3 times 2x, and that's how you get 6x. So that's called a constant multiple rule. So I'm going to give you a case where there's also constant multiple rule here. So what if I have 2x cosine of x minus 2 sine of x? So simultaneously, there's two rules happening. And if I want to take a derivative of this, and this. You want me to grade it?
I think I'll might come back later.
You come back later, okay. So it turns out right here, if you pay attention here, there is a product rule here. Do you see that? Do you see that? And I hear there's no product rule. That's called constant multiple rule. Constant multiple. So then if I were to take a derivative of this, it's basically this times this. So those two things multiply each other. One of the things cannot be a constant. If it's a constant, it's going to be automatic constant multiple rule. So if I do this, this is going to be 2, and then cosine of x, plus 2x times the negative sine of x. And let's take a derivative of this. This is very easy. Just pretty much take the 2 out, and take a derivative of the cosine of x. And that's it. So it'll be 2 cosine of x minus 2x sine of x minus 2 cosine of x, and 2 cosine of x cancel out. Then my answer is 2x sine of x. So that's a product rule.
So we just leave it in that form?
Yep. There's nothing I can simplify more. But you do see here that I don't need a product rule here, because it's not 2x squared times sine of x or 2x sine of x. It's just 2. If it's 2, it's like taking derivative like 2x squared, right? We just take a derivative of x squared. In this case, we just take a derivative of the sine x, then which is cosine of x.
So why is it, what happened to 3x in the problem?
Where's the 3x go? I don't see 3x.
Oh,
Yeah, I'm just to give you an example, what is a constant multiple rule? So this is a constant multiple rule because I pretty much leave the 2 alone and just take the derivative of the sine of x, it becomes cosine of x. I didn't need to do a product rule there. And that's what I'm trying to say. Okay? Okay, next thing is called quotient rule. So we know something times each other is fine, but what about something divide something? So the quotient rule here is this. What? That's your favorite rule? Okay, good. Okay, so a lot of time that they do this, they use an acronym to help you. So they'll say if for f of x over g of x, so if I take a derivative of this, it's going to be, remember this acronym, it's low d high minus high d low over low low. So low d high minus high d low over low low. So we're going to announce this function is high and this is low function. So we're going to say low d high minus high D low, and don't forget about low low. Low low, it's not low low here. It's gonna be g of x square. Okay. So this is a quotient rule to you. Then you say, okay, well, quotient rule. So now we're gonna use this rule to apply to this one. Okay, so one thing people forget is this. I'm gonna write down people usually don't forget is this. People forget this part. Don't forget the low square. The low low. Don't forget the low low. And don't forget there's a parenthesis right here, so that's going to distribute that negative sign to all the term afterwards, okay? So this is a parenthesis right here. Don't forget about this parenthesis because that parenthesis is going to help you to straighten the negative sign. A lot of you guys did a quiz on yesterday's, Friday's thing. They forgot to distribute it. You have to remember to distribute. So now we're going to give you a function. Says, hey, I have this function. And that's going to be 5x minus 2 over x squared plus 1. So I want you to take a derivative of this one. Remember, it's low, d high, minus high, d low, over low, low. Now, do not expand the bottom. The bottom, there's no reason to expand it. Just keep it as x squared plus 1 square, and you don't have to do any further. So I'm going to show you the rabbit again, let you guys think. What time we get off here?
58.
No, it's 27.
27? 8 minutes.
Wait.
That's for 5Bs, it's 5As.
Oh, yeah.
I looked through your test, I didn't grade it, but I will come back this afternoon if you have time.
Yeah, I might come back.
Okay. Yeah, we're gonna go through them all.
So I was really confused with number 10. What do you mean by B, normal line?
Normal line?
Finding both.
Yeah, we gotta find A for tangent line and B for normal line.
Oh, okay.
We talk about normal line, right? We said something about physics.
I think so. Oh, but I'll figure it out. Hopefully.
I'll give you a clue.
Oh,
I don't know if you know what that meant.
I hope I did. I think I picked up something, but it's plausible as something.
Plausible. If you're done, check with each other. Make sure you don't expand the bottom. The bottom is like, x squared plus 1 square. Don't expand it. Just keep that, right? Because I don't need to expand, but I do need to simplify the top. All right. You guys check with each other? So what we're gonna do is we're gonna do that. You're almost done?
Okay, this is this.
Yeah. Well, I squared part. That's all. I didn't like separate it in the vector. I just squared it. But yeah, I got the same top. Minus.
Wait, you
Yeah.
got the same X.
Yeah, I
Yeah,
got
I
that.
guess I got the same vector.
4x. Oh, I left the x out. Okay, I know what I did wrong. I left the x from the 2 out. I think so. Because then I get, then I square that one, and then that becomes x. I did it right.
You're good? No problem? Okay. I'm going to talk about 3 times, 3 situations you want to avoid quotient rule. 3 situations. Okay? 3 situations. And this might help Logan here.
No, sadly it won't.
3 situations you want to avoid quotient rule. The first situation is a polynomial over monomial. Why? Because poly over mono. So for example, you have 2x squared minus x minus 1 over square root of x. It's much easier to split out. Right, split this and then take a derivative from here, because your homework is going to have some of those. And then you can take a derivative from here. If you take a derivative from here, it's going to be much easier and much more cleaner, and you don't have to use a quotient rule, although some of you guys may say that's my favorite rule, but still, this is much easier than the quotient rule, because I can show you the comparison of those 2 rules when I'm asking you to do double derivative. The work is between half page or 3 lines. So you can make sure that do that. The second situation you want to avoid quotient is you have a constant on the bottom. Let's say 4 of x squared minus 3x. Why I would avoid quotient rule in this case? Because I can say d to the dx, I can say 1 over 4 times x squared plus 3x. Why? Because I can do 1/4 in the front and just do d to the dx of x squared plus 3x. And that's just going to be 1/4 times 2x plus 3. And that's it. You avoid quotient rule. So when a constant on the top, on the bottom, only constant, you avoid quotient rule, okay? This is a constant on the bottom. Constant on the top, also avoid quotient rule. So if you have 4x squared plus 3x to like 3rd power, like d to the dx. Now we haven't learned this yet, but it's going to be used something called chain rule. It's going to be much more effective. So if it's constant on the top, then it's going to be a chain rule. Constant on the bottom is going to be a constant multiple rule. Okay. So on today's homework, I'm going to give you all of them, kind of test you, see if you know which rule to use. So 3 situations, avoid quotient rule. So avoid quotient rule. The only time you use quotient rule is something like when you have expression over expression. You have variable over a variable, but bottom is not monomial. Bottom monomial, you just split them. And a lot of test question, ask Logan, right? Nothing. A lot of test question that he's taking right now, it doesn't require quotient rule. And guess what? People do quotient rule.
What situations do we avoid using the product rule?
No, there's no situation. Product rule, if you have two things times each other, you can always use product rule. But quotient rule is 3 situations, trust me. You can split them, or you can do constant multiple, or you can do chain rule. Everything's much easier to handle and to write rather than quotient. I know some people prefer quotient, but it doesn't work if I ask you to take a double derivative and stuff like that.